Is Nvidia quietly reshaping the architecture of the world's AI data centers? With the unveiling of its Rubin CPX at the InfraAI Global Summit 25, Nvidia just revealed a major step forward in realizing its vision of the next-generation AI factory, and the entire industry is taking notice. Let's pull back the curtain. Nvidia's Rubin CPX joins the up-and-coming Vera Rubin family as a new inference accelerator, working alongside the standard Rubin AI GPU. The aim? Delivering top-notch AI content generation with much lower costs. A crucial move as generative AI powers everything from text to video synthesis at breakneck speed. But here's where it gets particularly interesting. Nvidia isn't just releasing chips. It's rolling out a whole blueprint for data center infrastructure, made for flexible, multi-AI GPU environments. Why do data centers need specialized AI GPUs? It's more complicated than you think. Let's address a common misconception. There's no single universal AI workload. As Tirias Research has long argued, every AI model, whether from AMD, Intel, Nvidia, or beyond, places different demands on hardware. As the landscape keeps evolving, there's an ongoing opportunity to fine-tune or redesign hardware to fit specific model requirements. But, and this is the part most people miss, GPUs remain the backbone for AI training and inference, for two essential reasons that Nvidia is doubling down on with Rubin CPX. First, consider how technology matures over time. The semiconductor industry cycles between explosive innovation, where new solutions emerge daily, and periods when things slow down, giving way to standards. At some point, it becomes logical to develop dedicated hardware like ASICs, application-specific integrated circuits, which perform single tasks extremely well. And sometimes, these functions eventually get folded into CPUs or GPUs. But custom chip development can take years. With AI models changing so quickly, general-purpose GPUs offer much-needed flexibility and adaptability that ASICs simply can't match in the short term. Second, there's a persistent myth that industry is about to shift away from training to inference. The reality? Inference has long dominated AI centers, especially with the proliferation of tools like ChatGPT, Google Gemini, Microsoft Copilot, Anthropic Claude, Perplexity AI, and more. If there ever was a major shift, it happened years ago. Most AI work today is already inference-focused. Why? Because GPUs, with their programmable flexibility and powerful parallelization, facilitate running multiple complex models simultaneously, making them practically indispensable for the huge range of AI tasks being deployed. Inside Nvidia's AI data center playbook, beyond GPUs, at GTC 2025, Nvidia rolled out several technologies tailored for AI-centric data centers, from the NVL144 rack architecture and PayV cache, which lets GPUs share computed data for maximum efficiency, to Dynamo, an open-source framework that dynamically orchestrates and routes AI workloads. Nvidia also showcased data center blueprints that run within Omniverse, offering a virtual digital twin. For the design and management of AI data centers, which Nvidia now brands as AI factories. Now, Rubin CPX enters the scene, a context inference accelerator designed to tackle especially demanding generative AI workloads. Think multi-million-line codebases, extended video rendering, or intensive research tasks. In this disaggregated approach, the Vera CPU and Rubin AI GPU handle heavy data ingestion, while Rubin CPX jumps in for resource-intensive content generation. Thanks to its 128 gigabytes of GDDR7 memory and built-in video encoding-decoding, Rubin CPX processes a staggering 1 million token context window. And while it sacrifices some total compute, about 20 petaflops less than its sibling, It delivers 3 times faster attention acceleration and vastly improved performance for contextual token generation. Nvidia's data center configurations, raising the stakes. Looking at actual deployment, Nvidia plans to bundle the Rubin CPX, Vera CPU, and Rubin AI GPU into an all-in-one Vera Rubin. If you break out the Rubin CPX and GPU into distinct racks, you get the same computing muscle, just with even more memory. What about the future? And here's where debate sparks. Rubin CPX is clearly designed for AI's most demanding creative and analytical workloads. But expect this trend to continue as Nvidia, and perhaps its rivals, roll out new versions targeting specific workloads. From compact models for edge devices to even more specialized inference accelerators. The truth is, AI workloads aren't one-size-fits-all, and designing the right accelerator is just one piece of the puzzle. Nvidia's true focus is on orchestrating the entire data center as one holistic, optimized system. That's how you squeeze every last drop of throughput, efficiency, and ROI from your investment. Now for a provocative question. Are these rapid, almost yearly upgrades in AI GPUs actually helping the industry? Or could they be pushing organizations into an endless upgrade cycle? On one hand, annual product launches are currently necessary simply to keep pace with AI innovation. On the other, some argue this treadmill could pose long-term challenges for budget planning and sustainability. Do you agree with Nvidia's aggressive rollout strategy, or do you see it as a risk? Let's spark some debate. Share your take in the comments. Where do you stand on the pace and direction of AI hardware innovation?